In this video, we want to look at the concept of dividing a line in a given ratio. Looking at the first type of division of a line in a given ratio, that is the internal division. And in the next video, we'll talk about the external division. What does it mean to divide a line in a particular ratio or in a given ratio internally? In the previous video, we looked at how to divide a line into its midpoint, or simply put, how to find the midpoint of a line. We said if you're looking for the midpoint of a line, add the x coordinates together, divide it by 2, add the y coordinates together, also divide it by 2. And we're well aware of how we arrived at the formula by simply looking at the concept of similar triangles. Now that we want to divide this line in a given ratio, so let's say m to n, so let's say ratio m to ratio n. Now you can see that we are given 3 points, A, B, and C. So we want to divide line AC into 2, AB and also BC. AB will have the ratio of m, AC will have the ratio of n. How do we arrive at this? Okay, so basically what I've been saying in terms of the ratio, so let's say we have this here, from here to here, let's call it m, and then let's call from here to here, let's call it n. Now we want to do the same thing we did for midpoint by looking at the concept of similar triangles. Similar triangles. Now you can see that triangle BCF is a right angle triangle. Triangle BCF, a right angle triangle. Triangle ABE, also a right angle triangle. Okay. Now angle A will be the same thing as angle B because they are corresponding angles. Now that two angles are equal, then it must mean that the ratio of their corresponding sides will be equal to a constant. What do we mean? I can decide to take AB over BC. The ratio of AB over BC, by saying it to be equal to AE over BF. We're also saying it to be equal to BE over CF. So this is what we're trying to say. And lastly, this will be equal to M over N. Remember, we're trying to divide this line internally. So definitely we also need the Y coordinate. So how do we go about deriving our formula first? And then looking at how to apply our formula into solving for the division of a line in the given ratio internally. So like we did for the previous one, we can take any of these ratios. So I'm going to come and be using AEBF equal to M over N. So I'm going to clean this now and then rewrite it so we can see what we can derive from there. So like we said, we're going to be taking AE over BF, and then we're going to be saying this is equal to M over N. Now, what is AE and what is BF? Remember, if this point here is x1, this point here is x, and this point here is x2. So the space in between x1 and x will simply be x minus x1, and the space between B and C, or x and x2, will simply be x2 minus x. Now, what is my AE? A is simply x minus x1. What is BF? BF will be x2 minus x, okay, and this will be equal to m over n. Now, what do? I can simply cross multiply. So cross multiplying this, I'll have n in the bracket of x minus x1 will be equal to m in the bracket of x2 minus x. Now, since we're looking for x coordinates, so I need to open this bracket. Opening this bracket, n multiplied by x gives us nx. N multiplied by minus x1 gives me minus nx1, and this will be equal to, again, do the same thing, mx2 minus mx, isn't it? Now, group the x together, that is, take mx to the other side. We'll have, let me try and make a line here, okay? So we'll have nx plus mx, okay? And this will be equal to, so again, take nx1 to the other side. This becomes mx2 plus nx1. mx2 plus nx1. What do? You can see that I'm seeing x here, I'm seeing another x here, so I can try to factorize. So factorizing, we have x, and then this is n plus m, and this is equal to mx2 plus nx1. Finally, I can decide to divide both sides by n plus m, and I will be having x equal to mx2 plus nx1, so over n plus m, but since addition is commutative, I can write it as m plus n. Now, what does this mean? It means, before now, when we're looking for the midpoint of the line, we took the value of x2, we took the value of x1, and then we added their ratios together and divide them out. But this time around, since B is not dividing AC exactly at the midpoint, it means if I know the first ratio, that is m, multiply it with the second x value, which is what we've seen in this question here, mx2, then plus the second ratio that we're given, multiply it with the first x value and divide it by the sum of the ratios. Now that we've derived that of x to be mx2 plus nx1 over m plus n, then definitely we know that that of y would also be my2 plus ny1 all over m plus n. But let's see how we can derive that of y itself and see whether we arrive at the same expression we've written outside. Okay, clearing the screen now, we'll be having, okay. Okay, now we can take a different ratio. So since before we took AE over BF, now we want to take BE over CF, and say this should be equal to M over N. Okay, again, what is BE? If this is Y and then this is Y1, then definitely this will be Y minus Y1. And if this is Y2 and this is Y, then this will be Y2 minus Y. Substituting the value of BE and CF into these ratios that we've written, we'll definitely have Y minus Y1 over Y2 minus Y will be equal to M and N. Again, if we cross multiply, we have N in the bracket of Y minus Y1 equal to M in the bracket of Y2 minus Y. Okay, here we have ny minus ny1 equal to my2 minus my. Again, group the y's together and the ones and twos together also. So grouping them, we have ny plus my will be equal to my2 plus ny1. Okay, so y is common here, we can factorize. So factorizing this, we'll be having y in the bracket of m plus n. Okay, and this is equal to my2 plus ny1. Finally, divide both sides by m plus n, and then we'll be having y equal to my2 plus ny1, everything divided by m plus n. Okay, so now that we've written this, we can now write the outright formula for the division of the line in the given ratio. So we can write this as, okay, so let's translate this so we can have more space to write. Okay. Unlike that of midpoint, where we wrote x plus 1, x plus s1 plus x2 over 2, here division, so we can just write d, so you can put in bigger brackets. So for the x1, x will be mx2 plus nx1, everything divided by m plus n, comma, okay, again, my2, okay, let's claim this properly, my2, okay, plus nx, sorry, that should be ny1 over n plus n. All right, so this is the formula we want to use to find the division of a line in the given ratio, internal division of a line in the given ratio. So let's try and take a question. Let's see how we apply this formula. So we're given that P and Q divide the line AB. So if point A is given as A minus 1, 2, and B is given as 3, 4, that is the coordinate of A and B have been given internally in the ratio 3 to 2, we have to find the coordinates of P and Q. So here we're told that P and Q divide the line AB. So A is 1 minus 1, negative 1, 2, B is 3, 4. Internally in this ratio, we should find the coordinates. All right, so first thing we want to do is to try to sketch. Why are we sketching? Sketching helps, what's it called? Helps you solve your work faster. Now you don't have to sketch if you don't want to, but I'm just going to sketch for the sake of this example. Now after sketching, we have, let's say we have a line like this. So let this be my point A, and then let this be my point B. So at point A, I have minus 1, 2. At point B, I have 3, 4. Okay. Now P and Q. So let's say, for instance, we have P and Q located at this point. So that's what we want to find. P. Okay. So let's write this P, Q. So that's what we're trying to find. And then we're told that the ratio in which it divides it internally is 3 ratio 2. So from here to here, so let's call it 3. Okay. And from here to here, let's call it 2. Okay. Now the next thing after sketching is to write the formula. So our division formula would be, so you can just write mx2, okay, plus nx1 over m plus n, okay, comma, again my2 plus ny1 again over m plus n. So after writing this, then we can now deduce which one is our x1 and x2 and which one is our y1 and y2. So let's take point A as the ones. What do I mean? So let this be my x1, let this be my y1, and let this be my x2, let this be my y2. Now I'm going to be solving this in two different ways, just so that whichever method you want to use, you are comfortable with it. So firstly, we use the formula. Then secondly, we just go to the direct approach, how to get there. But the goal is to get the same answer. So do well to stay tuned. All right, so using this first one, so since we've talked about the formula, so we can now say, okay, the x value now, that is for the x. Okay, so let me not use x again, since the question said P and Q. So let me write P. So P will simply be equal to, remember, P is representing the abscissa now. So this formula, M, so M here, the first ratio, 3 in the bracket of, what's my x2? My x2 is 3, so 3 in the bracket of 3, plus n is 2, 2 in the bracket of, what's my x1? So x1 is negative 1. So I hope you're getting what I'm doing. We're giving 3 ratio 2. So m is the ratio that comes first, and n is the ratio that comes after. So remember, the formula said the first ratio multiplied by the second, or x2, then plus the first ratio, or plus the second ratio rather, multiplied by the first x value. So that's what we've written here. So 3 is the first ratio, which is this 3. Then the x2 is 3. So that's why it is 3 multiplied by 3. Plus n is second ratio, which is 2. Then multiplied by negative 1. So which is what we've done here. Then what do? Just add the ratios together to get the value of P. Okay, 3 times 3, that's 9, plus 2 times minus 1, so that's negative 2. So we have minus 2, and then this is 5. Okay, and then our answer here is 7, or 7 over 5. That's for P. Now for Q again, applying our formula, M again, which is 3. Now what's my Y2? My Y2 is 4. Okay, then plus, what is my N? N is 2. And what is my Y1? Y1 also is 2. And then 3 plus 2 also. So this is equal to 3 times 4, we're having 12. And 2 times 2, we're having 4. So this is 5. 12 plus 4, that will be 16 over 5. So we've gotten our value of P to be 7 over 5. And for that of Q should be 16 over 5. So I'm going to come and write it here underneath here so that when we use the second method, we'll see whether we're arriving at the same answer. So we can now decide which of the methods we want to use. All right, so using the second method, so what do we want to do? What do we want to do? All right, so, or the direct approach rather. Now we sketch this. So what I'm going to be doing is, I'm going to be dividing the ratios of the distance. You can say this is point P, isn't it? So let me call point P as, so I'm going to be writing this as, so this P comma Q, so I'll assume P to be my X axis and Q to be my, what's it called, Y coordinates rather. Okay, so here we have, so I'm going to be writing them as a ratio of each other. What do I mean? The X value here, the X value here, and the X value here. I want to take the ratios and equate them to this ratio I'm saying. So basically what we're doing is minus 1, you can see minus 1 is the X value I'm having in point A. So I'm taking P as the X value I'm having at this midpoint. So minus 1 minus P. So you see what I'm doing? Minus 1 minus P. Okay, all over again P minus 3, and we're saying this should be equal to 3 over 2. Okay, so let's quickly cross multiply. Cross multiplying this, I have 2 in the bracket of negative 1, negative P. Okay, and then I have 3 in the bracket of P minus 3. So this is negative 2, negative 2P. Okay, equal to 3P, and then what's it called? 3 times negative 3, so we have negative 9. Okay, combine the like terms. 9 goes to the other side, it becomes positive 9. So I have minus 2 plus 9. Minus 2 comes to this other side, becomes 3P plus 2P. Okay, this is 7, this is 5P, and P finally is equal to 7 over 5. So you can see we're getting the same P value we got when we applied the formula. Okay, so quickly let's get our Q value then using the direct approach and see whether we have the same answer. So we want to do the same thing we did, but this time around for the Y value. Okay, for the Y value, what do? We say 2 minus Q and take it and Q minus 4, and then we equate it to 3 over 2 also. Again, what do? Cross multiply. Cross multiplying this, we have 2 in the bracket of 2 minus Q, okay, and 3 in the bracket of Q minus 4. So after doing this, 2 times 2, we have 4. 2 times minus Q, that's minus 2Q. 3Q, okay, and then 3 minus 4, or 3 times minus 4, that's negative 12. Again, combine like terms. 12 goes to this side, becomes positive. So we have 4 plus 12 is equal to 2Q comes to this side, becomes positive. 3Q plus 2Q. All right, so 4 plus 12, we're having 16, and 3Q plus 2Q will be having 5Q. And finally, Q will be equal to 16 over 5. All right, so you can see that we're having the same answer. So whichever one you feel comfortable with doing, just in case you can't remember the formula, you can also come the direct way and finding the internal division of a given line, given a specific ratio. So this is all I have for you for this video. In the next video, we'll talk about the external division of a line segment given a particular ratio. Thank you, and bye-bye.